welcome to 9-7 puzzle problems. To be honest, I don't remember what this section is about. It is chapter 9, so I'm assuming it deals with two variables and two equations, whether you're creating those two equations, whether you're relating them, and I'm assuming that they're going to be complex or complicated, which is fun and exciting and something that we look forward to tackling and using our experience. So the sum of the digits of a two-digit number is 10. The new number obtained when the digits are reversed is 18 more than the original number. Find the original number. So I like these problems because we think about how can we, here's a little preface to this, how can we represent values of numbers through variables. So if we think about it, if we think about the number 23, right? We can't just go 23, x equals 2 and y equals 3. That doesn't work, because if we tried to represent it as x, y, well, that would be 2 times 3, which equals 6. That wouldn't work. And if we put, you have to think about it. So how do we get the x in the tens place? Well, we're going to have to do maybe 10x plus y. Well, 10x, 10 times 2 plus 3, 20 plus 3 gives us 23. So this would be a good representation of a two-digit number. The x being the tens place and the y being the ones place. So very important, something that you have to take some time and think about it logically. So the sum of the digits in a two-digit number is 7. So this we can do. We'll do 10 and we'll do a little slash for the ones. So tens place plus ones place equals 7, because we're just taking the value in the tens place. The new number obtained when the digits are reversed is 27 less than the original number. So the new number, so that's 10O plus t, that's the value of the new number, obtained when the digits are reversed, that's reversed, is 27 less than the original number. So if I take the original number, so this is equal to the original number, which is 10 times t plus o, the ones place, minus 23, or 27, sorry. So if I subtract 27 from the original number, it should equal my number reversed. So now we have two equations. This one we have to simplify a little bit. So let's move the variables over so it's in the same format as this top one. Remember, that was really important. If we're going to be in ax plus by equals c format, make sure both equations are in the same one. So I'll minus the t's over, I'll minus the o's over, and then we will simplify. So we get 9o minus 9t equals negative 27. So we'll use this equation and use this equation. Now, what technique do we want to use? Remember that we have graphing, we have substitution, and we also have addition and subtraction. So let's just try substitution for the first one. So we'll isolate t, which gives us 7 minus o, and then where we see t, we will substitute this value in for t. So we have 9o minus 9 times, instead of writing t, we write 7 minus o equals negative 27. This is fun. Hopefully you see this is fun. 9o minus 63 plus 9o equals negative 27. That gives us 18o minus 63 equals negative 27. Let's add 63 add 63, 18O equals 63 minus 27 gives us 6. We had to borrow 36. 36 divided by 18. Divide by 18. And we get O equals, what's that, 2? 8, 9, 16? 2. So the ones place is 2. And then we can go back and use the other formula right here. So we have T. So T equals 7 minus, what was O? It was 2. 7 minus 2. So my tens place is 5. So my tens place is 5. My ones place is 2. Do we want the original or the new? Find the original number. So remember, we placed T as the original. Here's my original. So my original number is 25. Original number is 25. Cool. And then we can check it. What's 2 plus 5 is 7. If you take the new number, 52, so if we're checking, does 52 equal the old number 25? Sorry, does the new number obtained when the digits reverse 27 less than the original number? Ooh, maybe I did that wrong. Is it find the original? Oh, the original number. Hello, tens place 52. Hello. The original number is 52. That was I didn't make a mistake. I just didn't write the 5 in the tens place, the 2 in the ones place. This is ones place. This is tens place. So the original number is 52. My bad. So and now we're checking. Sorry. Let's check. Check. 5 plus 2 is still 7. Does the new number, so the new number is 25, equal 52 minus 27? Does 25 equal, yeah, 25. 52 minus 27 is 25. And it works. So my original number is 52. Sorry about that. Didn't mean to confuse you. A two-digit number is 7 times the sum of its digits. A two-digit number, so 10t plus the ones place is 7 times the sum of its digit. So if we multiply 7 times the sum of its digits, t plus o, there's our first equation. The tens digit, the tens digit is 3 more than the units digit. So units plus 3. Okay, we got our two equations. We don't even have to do anything. We can already substitute because we have what t equals, so we can substitute it into here. You might want to, oh, u. I didn't mean to do u. I meant to do o. Units. That's why I would do u. Units. Instead of ones place, the units digit, I should probably use u. Sorry. Let's do u. Let's use the variable u. Then we don't have to worry, although I did like because I don't like writing u. U is so hard. I like ones digit was so much easier. All right, we're going to take that and we're going to plug it in for t, so we get 10. Instead of writing t, we're going to write, see, I'm already having a problem. U plus 3 plus u equals 7 times the quantity. Instead of writing t, we're going to write u plus 3 plus u. Me? No, u. 10u plus 30 plus u equals 7 times the quantity 2u plus 3. That's going to be 11u plus 30 equals 14u plus 21. Let's move the u's. Let's move the constants. And we get 9 equals 3u, divide by 3, divide by 3. 3 equals the units place. And then we can go here, and we can say t equals 3 plus 3, which equals 9. So the tens place is 9, so my number is 93. Let's check it out. Is 9 equal to, not 3 plus, good Lord. All right, yeah, we've reached that. We've reached the melting point, kids. Because you must have been like, what is he doing? Why is he writing 9? Because I'm human. 63. Hello. And I checked. Does 6 equals 3 plus 3? Yes. Does, let's checking. So does, using blue, we're going to check. Does 63 equal 7 times 6 plus 3, which is 9. Yeah, 63. Yep, 63 equals 63, 7 times 9. So that worked, even though I tried to mess it up. Example 2. Chan is 3 years older than Myra. 6 years ago, Chan was twice as old as Myra was. Find their ages now. Those are so tough. And then example 3, the denominator of a fraction is 4 more than the numerator. If 2 is subtracted from each, the value of the new fraction is 1/5. Okay. All right. Let's give it a shot. How many of these we got? We got 4 of them. So this is a manageable section. Hard, but manageable. Max is 5 years older than Paulette. So let's do Max equals Paulette plus 5, because he's 5 years older. If you add 5 to Paulette, you'll get Max's age. Next year, he will be twice as old as she will. So Max plus 1 year is going to equal Paulette's age . So that's Paulette's age in 1 year will be 2. If we double it, that'll equal Max's age in a year. So let's use the substitution. We are set up for that, right? We have M in terms of P. So let's take M and plug in P plus 5 plus 1 equals 2 times the quantity instead of, oh, nope, that's it. 2 times the quantity P plus 1. We only have 1M. So that's going to be P plus 6 equals 2P plus 2 minus P minus P minus 2 minus 2. 4 equals P. So Paulette is 4. Hold it each now. Paulette is 4, and Max is 10. No, 9. 9. 5 years more. In a year, Max will be 10. So checking. Max in a year will be twice as much as Paulette is in a year. So yeah, 10 equals 10. So that worked. So this is correct. Paulette is 4, Max is 9. That worked out okay. Gloria is 20 years older than Reggie. So Gloria is 20 years older than Reggie. So if we add 20 years to Reggie, we'll get Gloria's age. 5 years ago, she was 5 times as old as he was. So 5 years ago, if you subtract 5 years from Gloria's age, she was 5 times as old as he was. So if we have Reg minus 5, because that's 5 years ago. So this gives, we can again use substitution. We know what G is in terms of R. So instead of doing G, we're going to do R plus 20 minus 5 equals 5R minus 25. We're distributing that 5. We get R plus 15 equals 5R minus 25. Let's move the R's. Let's move the years. We get 40 equals 4R. Divide by 4. Divide by 4. We get Reggie is 10. So Reggie is 10 and Paulette, or Georgia, so Georgia equals 10 plus 20. So Georgia equals 30 years old. Reggie's 10, Georgia's 30. That works on the top equation. 25 equal 5 times 5. Yeah, that works. Okay, we're doing good. The denominator of a fraction, so we have a numerator and denominator. Numerator, denominator. So the denominator of a fraction is 7 more than the numerator. So denominator is 7 more than the numerator. So if we add 7 to the numerator, we'll get the denominator. If 5 is added to both the numerator and the denominator, the value of the resulting fraction is 1/2. Woo! If 5 is added to both the numerator, so numerator plus 5 over denominator plus 5 will be equal to 1/2. All right, so there's 2 things we can do here. First, we're going to use the substitution. We're going to substitute this value in for D. So we get n plus 5 over, instead of writing D, we're going to do n plus 7 plus 5 equals 1/2. We can simplify that. N plus 5 over n plus 12 equals 1/2. And now we're going to cross product. Cross, cross, create an equation. So we get 1 times n plus 12 equals 2 times n plus 5. N plus 12 equals 2n plus 10 minus the n minus the 10. We get 2 equals n, so the numerator is 2, and the denominator, so the denominator equals 9. So my fraction is going to equal 2/9. If we add 5, that's 7. Add 5, that's 14. That simplifies to 1/2. Nice. Yeah. The denominator of fraction, denominator, is 1 more than the numerator. So numerator plus 1. If the numerator is decreased by 1, the value of the resulting fraction is 3/4. So nothing to the denominator equals 3/4. That's it. Good. Let's use substitution again. We'll substitute this value in for D. So we get n minus 1 over n plus 1. We substitute in for D equals 3/4. Cross product. Cross. Cross. Our new equation is 3 times n plus 1 equals 4 times n minus 1. 3n plus 3, 4n minus 4 minus 3n minus 3n plus 4 plus 4, 7 equals n. That equals the numerator, and the denominator is going to equal 7 plus 1, or 8. So my fraction is going to be 7/8. And if we subtract 1 from the numerator, it becomes 6/8, which reduces to 3/4. Wow, that was a nice, quick video, something succinct, something, again, excellent opportunity for you to become more proficient with word problems, getting these in your wheelhouse so you can be proficient. Good luck, enjoy, have fun.